Hey, how are you? Did you hear that Huштef is coming? Yes, and this year it's going to be better than ever. We have a lot of amazing talks and I'm really looking forward to see you there and join me for my talk and let's all have some fun. See you there. Bye. Hi, it's Corina. How are you doing? This is my fourth Huштef and this year, just like every year, I want to discuss a little bit about automation. My talk for today will be around some of the worst mistakes you can make in automation. These might not be all of them, so there might be so many more mistakes that we can make, maybe some even worse. But I've decided to pick a few that I've seen frequently in the projects that I've worked on, and I want to encourage you not to make the same mistakes and to help you a little bit, see a perspective that might help you with your project. So, let's get started. So let's start with one of the first things or the most important things that we need when we get started with automation, and that is understanding the programming languages or the tools or the frameworks that we're going to use in our automation. Now, many times you are asked to do automation without any prior knowledge of those frameworks and those programming languages. And, management does expect results really fast, really soon, because that's what they do. And unfortunately, sometimes we just don't have the time to read properly the documentation and to start doing the automation fully knowing how to use those programming languages and frameworks. This is a little bit bad. Okay, I'm not gonna lie. This is really bad because when we start doing automation this way, we don't know anything about best practices on how to use those languages, and this leads to way too much code, incorrect code that needs a lot of refactoring, and it's just not going to work properly. We might even get some false positives in our tests because we didn't use certain constructs of that language in the proper way. So before we start doing any automation, we really need to understand at least the basics of those programming languages or tools. Otherwise, it's going to be a little bit of a chaos in the project, and nobody wants chaos in the project. That's not good. That leads to a lot of refactoring and, having a lot of code thrown to the garbage, and this is not what we want. Ideally, what we want is when we start doing the automation, we should start doing it the right way, the proper way, and in an efficient manner for us to use it many years from now on. After we started with the automation, and we've already learned the basics and so on, we need to also understand that we need to standardize the project. Meaning we have to have a set of rules that everybody follows when it comes to pushing the code into the repository. For example, we should have a standard on how to name things. We should have certain locations where certain types of code needs to be placed. Now, I'm going to talk a lot about code during this talk because I write code. I don't normally use tools for automation. So, yeah, you know what I mean, but this is, valid even for some of the utilities that you have in tools that you might use instead of programming languages. The idea is that when you're writing code, nobody should be able to say that this code was written by a specific person, because everybody should follow the exact same rule. No breaking the rules, Typos. Typos are some of the things that we overlook a lot, because we think that typos are something that are not very important. However, because of typos, we might not find the code that we're looking for, or somebody who comes into the project looking for something will not find what they're looking for because they're searching for a name for maybe a method or a variable, and the name has a typo. So they're not going to find what they're looking for, and they will just start writing additional code, which will lead to duplicate code and so on. So we don't want that. We want our project to be clean and to have a high quality. We want to pride ourselves in the quality of our products which we deliver to customers, but also in the quality that our framework, by means of which we are testing the product, to have the highest quality possible. So it's up to us to standardize the project and to make it in such a way that the code is beautiful, it's properly structured, everything is in its place, everything is easy to look for, it's maintainable, scalable, and so on. You know what I mean. So standardizing the project is just one of the steps that you can take in order to make sure that the project is viable for years to come. Otherwise, again, you might get into some chaos because nobody knows where is what or what is what, and so on. And no exceptions, you know. Don't say, oh, just this once I'm going to break the rules and I'm going to do this. Because once you say just this once, it's not going to be just this once. It's going to be many, many times from now on. So try to enforce a set of rules for your project, write them down somewhere so that everybody has access to those rules and so that everybody knows what rules they need to follow when working with your project. Once we have written the code, let's not just keep it to ourselves. Let's share it with other people. Let's do code reviews. Code reviews are one of the easiest way to share the information about what is in the framework. If we write code in isolation, like we run it only on our machine, we don't tell anybody about it, we just commit it to the repository and that's it, people will not know about what we have written. And maybe some other people can use what we have written. Maybe it's something that is very useful for them and they don't need to write exactly the code that we wrote because they can just use what we have written. Without code reviews and without telling anyone about the things that we have written ourselves, they won't know about them. So there will just be a lot of duplicates in the code and, you know, that's not very helpful. Code reviews are very important, especially because they are a learning process above all. So it's not a finger-pointing process, it's not a blaming process. People will see something different. People will see and will hear different opinions about the code they wrote. Nothing bad about it. Sometimes, based on code reviews, you can actually improve the code that you've already written. Now, sometimes the suggestions you might get in code review are not necessarily the best ones. You know, maybe the code you wrote is better than the suggestions you got. However, many times it helps to see a different perspective from someone, especially if it's, let's say, developers who have way more knowledge in using the languages, the programming languages, in most situations than us. So their feedback is very important for us, again, to create clean code and usable code and maintainable code. When we have suggestions from reviewers, we need to consider whether the suggestions are worth implementing in the framework. And they're only worth if they are making an improvement either in terms of how much code we have or how easy it is to read the code, or if the tests are better in terms of performance. However, if they are not, then we should just disregard these opinions. Simply rewriting the code that we have for no particular reason is not okay. So code reviews should bring useful additions to the framework and useful improvements to the framework. When we get started with automation, we need to analyze what it is that we want to automate. We need to pick a set of scenarios that should be automated, which cover a wide range of things. For example, we need to check the scenarios, and we need to have some basic scenarios, some short ones, but also some very complex ones, some scenarios where we need to go through a lot of steps in order to achieve the automation. This way we can see how certain frameworks that we want to pick can handle these scenarios. Because sometimes if the software that we're testing, for example, is very heavy on, let's say, JavaScript, certain tools won't be so keen on testing them properly. Maybe they won't properly behave when it comes to those particular scenarios. So having a varied set of scenarios to automate gives us the opportunity to properly evaluate the frameworks that we're going to use. This way, if we are doing a proof of concept, a POC, we can see how easy our application is to automate. We can even see if it's automatable, because in many cases we have all kinds of third-party pieces of the software, or we have all kinds of legacy code in our software, and it might be very difficult to automate those pieces. It might be even impossible. But without doing a POC, without really committing to creating the automation, we won't know if the automation is doable. So we need to do a proof of concept. We need to prove that the software is automatable, first of all. And second of all, we need to see what is the best framework to use and how long it will take for us to do the automation. Doing a POC kind of gives us an idea about how long each of these scenarios will take, how long each of these pieces will take, because, you know, we might have pieces that are similar to those that we already automated, so then we can have an idea about how long it will take to automate those particular ones. We also need to see, or we can see from this POC, what kind of tweaks we need. For example, do we need a lot of timeout related, you know, wait methods and stuff like that. POCs usually are very revealing in terms of if you can do automation and how long it will take you and who can do the automation. Because in many cases, you know, you have automation that's easy to do by anyone, even by beginners, but in other situations, the tasks to accomplish are more for experienced people. So because you have a lot of complex things going on in the application that you're testing. So a POC can give you an information about who, when, how, and how long this automation can take, and even if it's feasible at all. One of the worst things you can do actually is picking the wrong framework. Because sometimes if you're not doing a POC, you might be inclined to use a particular framework that you either heard about or that you are familiar with. But that doesn't mean it will always suit the testing needs. As I said, sometimes applications are very complex. If you have front-end specifically, then it can be quite heavy, and you can have, Ajax calls and all kinds of behaviors, all kinds of things that pop up in certain ways based on how the framework is bringing them into action. Some of these frameworks that are available are not suited for what you're trying to automate. So in order to do when you're doing the POC, you get the good information regarding the framework to be used. So don't just pick a random framework that you know just because it's either hyped or, because you know about it. Pick the right framework. Otherwise, it will take a lot of time for you to migrate the work you've already, written in the initial bad framework and to migrate it to a better or to the right framework. You would have also wasted a lot of time writing those tests when in fact during that time you could have, created the test in the correct framework or at least done the proof of concept that I was referring to in the previous slide. Now, this is something I've seen quite a lot, and unfortunately, this is one of the worst things that you can do in automation. So let's consider the following scenario. You wrote some code, or somebody else in the framework wrote some code. That code is not the right code, so it's really, really bad. It does something that it shouldn't be doing. Or even worse, you have done something in the architecture of the framework which does not work properly. For example, the way you have chosen the environments, let's just say. Something that is related to the way you are configuring your tests to run either on an environment or a different one, or maybe to start the browsers and so on. So let's say you found that there is a problem with that code sometimes when there's around maybe 20 usages of that code. So it's already used maybe in 20 tests or 20 classes or something like that. You're thinking you can't change it because it's already used in 20 places. And you're also thinking that, okay, me or somebody else spent time writing that code. Why would I want to change it? Well, even though it doesn't work. Well, this is bad because, right now you have maybe 20 usages, which is decent. It's manageable to change the code right now. However, a few years later, you might be in the situation where you really won't be able to change it because it's already used in 1000 places in the code. People know about the code, they think it's doing, well, something good, and they're just using it in their code, right? Sometimes you have a method which inside it has some code that doesn't really work well, but based on the name, people are using it because they think it's doing something that their tests need. When it comes to, you know, having 1,000 usages, well, then it's really, really difficult to change or to remove that code. Removing it is especially tricky because if you have a programming language where you're using that code, removing the call to a method is really, really difficult. You need to go to like 1,000 classes or 1,000 test methods and manually remove the usage there. Unfortunately, if you keep the bad code in the project, what's going to continue happening is that people are still going to use it. So instead of 1,000 usages this year, next year you will have 2,000 and so on and so on and so on. Unfortunately, the side effects of that bad code will kick in and the framework might become unusable, especially, as I said, if the problem is in something regarding the structure of the project or the configurations, in the architecture of the overall project. So a few years later, after you found the problem initially, it's going to be like really, really difficult to remove that code. What you can do, one of the options that you have available, if let's say the code is in a specific method so that you can localize it there, is to just either delete the code from that method entirely and leave the code usage still in place. So you still have some code that is calling your code, but it's not going to do anything because the methods will be empty. Or you could even try to deprecate those methods. So you could just mark them as not to be used, but of course nothing will stop people from using it, even if the code is marked as not to be used. Deleting the code, of course, is going to be very difficult. It's going to take way more time than if you had deleted it years before. So you might end up in a situation where you might need to create a brand new framework just because of that one small problem that you found, which became a very, very large problematic situation. So whenever you see that, you know, you have found the code, you know how to fix it, you know how to improve it, even though if it's 20 usages, okay, it's fine. Don't think about the fact that you wasted time creating that code, because what you've done, in fact, is, yes, you have tried something, it didn't properly work, and now you have the option to change it to something better. You've learned what doesn't work, and now you can change what doesn't work to something that actually works, and so the framework will become stable, the framework will not have issues because of that code, so don't be afraid to change it or delete it, not a problem. Just make sure that the framework is working properly, because that's the most important thing when it comes to the automation. And when you create your tests, you know, sometimes you have those test cases that you need to automate, and sometimes the test cases are quite large. So maybe you have like 100 steps in a test case. Don't create all the tests at once, okay? So even though you are clear in what steps need to be taken, just group them in smaller pieces and, you know, create small tests at the beginning. Start with the first tests, start with the first steps, see that those steps work properly, and then continue adding steps and running again the tests and adding steps and so on. Unfortunately, many times we are creating the very long test because in the test case it's rather clear what we need to do. So especially when it comes to UI tests or to web tests, even though we know exactly what steps our tests need to perform, it's not okay to write all of them at once. So we do know that we need to access a certain page. We need to click on a certain button. We need to then check for some text, and then we need to click on something else again. For us, it's pretty straightforward. We know exactly the sequence of steps that need to be done. However, because this is UI, many times we will need to add all kinds of weights so that the tests are reliable and that they don't fail. However, if we don't create small pieces, we won't be able to stabilize the test. Having 100 steps in a test is going to make it really difficult to debug the test and figure out where we need to add those weights. If we run the same test, 10 times, because it's so long, we will never get to the end of it the first time before we update it to make it properly, because it will randomly fail in different places where these weights are needed. So instead of, creating the very large test at once, we should create small steps. So we should start with the first steps, run them several times to make sure that they are running properly, update them until they run properly, tweak them, fix them, and so on, and then add the next few steps, and then rerun the entire test, and then the next few steps, and rerun everything. So this way, if we are adding piece by piece by piece, once we have run the test for each of these small pieces, we already have a pretty good understanding of whether, for example, whether the first piece is seriously reliable, so to say, because we've already run that small piece 100 times probably, right? We also have a lot of information regarding the second piece. So running the tests many times will allow us to make tweaks here and there. But if we have all of these steps at once, it's going to be so tricky to figure out where we need to do the tweaks and to actually have the test run properly, because every time we will rerun them, as I said, problems will be here, then problems will be there, and so on. Small, nice, that's going to help us a lot. And of course, when it comes to, small pieces, ideally we shouldn't really have automated tests that have so many steps. So ideally, our tests should be as small as possible, because otherwise too many, especially too many UI actions might cause failures along the way, and it would be really difficult, and it would take a lot of time to stabilize such a test. So if it's possible, create smaller tests, of course, where we can, because sometimes we need to create, an automation scenario that covers a whole lot of things. And as I said, tests can randomly fail if they are not properly, ran and created and stuff. I see that in many cases we are just happy to retry the test over and over and over again, instead of taking a look at the reason for failure. Many times I see that people don't use, for example, debug, and they don't fix the tests. They just leave them there. They know the reason for the random failure, or people expect the tests to fail at a certain point randomly, but they are not fixing the tests, and they are not debugging to see how they can fix it. They don't really understand why it's failing there. So in this situation, a test that could be a pretty good test, because it checks for something that is important to you, otherwise you wouldn't have automated, just becomes irrelevant. The test is not reliable. We run it 5 times and we have different results every time. How can we rely on that test? We can't. So some of these tests might just become irrelevant, they might be thrown away, and people will not even look at them. Even if they fail, people will not look at the failure result, because they expect the test to have failed for a reason that they already know. Because of this, many times when the tests fail for a different reason, people will not pick that information up, because they will not look into the test. We know that that particular test is failing for that reason, and so we're not going to look at it, and this is how we're going to miss a lot of bugs, unfortunately. And having these tests that randomly fail and not fixing these tests will also lead to them not being a part of the CI/CD. The whole idea is to have a CI/CD pipeline. We do create test automation because we do want automatic deployments, automatic builds. If we cannot rely on our tests, then we cannot contribute to this CI/CD objective. So our tests are kind of irrelevant. Our purpose when we're doing the automation is to be able to continuously test the application. So for that we need reliable tests. Without reliable tests, we won't be able to continuously test the application. We're kind of doing useless work. So we should avoid that, and we should always look at these tests that are randomly failing and fix them. Especially if they are randomly failing, we can adjust them in such a way that they will run properly and that they will have, repeatable results. This means every time we are running the same test, if the build that we are testing and if the environment on which we are testing did not change, those tests need to have the exact same result. Okay? Yeah. Something else we don't always do is document the project. So when we are working on an automation project, somebody taught us how to use it, right? It's probably a colleague of ours who showed us how to install the project, how to configure it, and how to run it. And I see that in many cases the teams working on frameworks will not create the documentation for this project, and they are happy to just share the knowledge, from a person to a person. Instead, if we created a documentation where we would say, okay, this is how to configure the project, this is where to download the project from first, this is how to run the tests, this is how to create the tests, this is how to update the tests, it would be really easy for everyone to understand how the framework works. When somebody new comes to the team, we wouldn't have to have 1 or 2 people spending I don't know how much time with that person showing them how to use the framework, because they could just refer to the documentation and they could set up everything based on the documentation. It would be a win-win for everyone. The new joiner would have all the required things to get them set up, and the people who would normally need to do this training could focus their efforts on doing something else, like proper automation. It will also help even for people who are working on the same project on a regular basis, because, sometimes you just forget things. You are not going to remember everything all the time. So it would be good for you to have a reference to look into when you are working with this automation project and when you have doubts. Also, if you are at one point handing over the framework to someone else because, let's say, it has become maintenance, then it would be good for those people to also have the documentation available, for them to know how to run the tests and how to set everything up and so on. Again, instead of having people spend time sharing this knowledge, the people who need to have the knowledge can read it from the documentation that we created. And of course, when we are doing documentation, it's very important to keep it up to date. Don't just create it and leave it there and don't change it once you are changing something in the architecture or the project structure. Always update the documentation. Make it a living document. Make it evolve together with the evolution of the framework. Make it always be in sync with the project, otherwise it's useless. Now, automation. We need to create automated tests, but when do we have enough time to do automation? Never. However, we need to achieve our automation targets. We need to automate the right scenarios. If we are pressured by time to only automate certain test cases, then we should properly prioritize what are those test cases that we will automate. We always need to pick the most relevant and the most important test cases first, so that if we run out of the time allocated for automation, we don't miss automating what's important. Happy flows should be automated definitely first. So that's like the most important thing. Forget all about the edge cases and, those corner cases and stuff. If you didn't automate the happy flow, you basically didn't do anything. You just wasted time doing automation, but you won't have the most important tests to run because, you ran out of time. So what's most important should always go first. And if you ran out of time and there's no time for you to automate everything else, no problem. Just create some tickets for, like Jira tickets, for the tasks that you still need to do, and then prioritize them in, future sprints when there's nothing left, like there's no activities for you to do. You can pick some of these tasks within a sprint when, let's say, the environments are not working and you cannot run anything, or when there is no task for testing because we are in the middle of development and development still hasn't released any feature to be tested. Use those times that where you don't have that much to work to pick up these tickets and work on them, and just, eliminate the automation debt by looking into those tickets. What I usually like to do in case this happens is to just group these tickets under a epic or a user story so that I know what is the one place where I will look and find the automation debt tickets, and I like to pick them one by one, again based on priority, and just make the automation debt backlog smaller and smaller every time I can. Now, we create tests. We do create a lot of tests. Sometimes, however, our tests become obsolete because the feature that we're testing maybe just isn't in production anymore. Or because, we have changed the product that we're testing so much that it really is not worth updating our tests, because we should just write new ones. It would be faster than updating the old ones. In this case, we should drop the old tests. We should just get rid of them. I know people are very sentimental, are very attached to the code that they write, and they wouldn't really want to delete anything, but in many cases, this is a good option. So if these tests are obsolete, they cannot be used anymore because, as I said, maybe the feature isn't there anymore, we should just delete the tests. There's no point in keeping them in our repository. Deleting them doesn't mean they are lost forever, because in our version control systems like Git or SVN or whatever we're using, there is history. So we can go into the history of the project and we can recover them in case we need them at a later time for anything. So it's not like they're lost forever. They are still there if we need them, but many times we won't. However, if you are very reluctant to delete these tests, you could just move them to a dedicated folder. So sometimes I would create a folder that is named, for example, deprecated tests or obsolete tests, and I would move all of these types of tests there, just so we know that we still have them and that they're in a place from which, for example, they won't be picked up by Jenkins or whatever CI pipeline tool we are using. So we can just store them in the project somewhere where they are not causing any issues because they are not actually run. We could also disable them, so we could just use an annotation from testng or junit or whatever you're using, and you could just disable them and make sure this way definitely that they will not be run. But keeping a lot of code which is unused is just going to make your project larger and larger and larger. You will have way too many files in the project, way too many lines of code, and downloading projects with tens of thousands of files and so on takes a lot of time. Syncing such projects with the repository takes a lot of time. So keep in mind that doing so is going to cause some performance issues. Another mistake we can make is actually not running the tests that we have. So you spend time writing the tests. Why? Because we need them. And I'm not talking about the obsolete ones. So let's talk about the ones that are actually, functional and working and, valid at this time. Sometimes you just don't want to run them because they take too much time, right? Maybe you have some medium duration tests which take hours to run, or sometimes you even have tests that will take days. However, if these tests are validating your current product, there's no excuse not to run them. And what you can do is, because you have the pipeline available, you have maybe a Jenkins tool available, you can create either nightly builds or weekly builds to run these tests. Now, when it comes to nightly tests, you could run those tests that take hours, right? So, of course, the night has, I don't know how many hours, let's say 12 hours. So you have plenty of time to run those tests every night. Of course, if there is no deployment going on or any cleanup for that environment where you're running the tests. It's the same with the high duration ones. If they take days, you can start running them, let's say on Friday, after close of business, and have them run throughout the weekend. They have quite a few days available to run, so by Monday when you come back to work, you could see the results. And again, this is in the case where the environments don't get refreshed over the weekend. And this is also good because during the weekend, usually, when people don't work, deployments are not made to the environment where you're running the tests. So there's a good chance that they can, run successfully without being bothered by any deployments and stuff. Make sure to pick an environment which is stable so that you have good results there. So if you have an environment which is, let's say, up to date, really close to production, and with the latest code available, then that will be the greatest environment where you can run the tests. Otherwise, just pick one where you either have the latest code or it's almost the latest code, but at least it's stable, it works fine, and you have all the required things there, like all of the dependencies and all of the data that you need. When we are writing the tests, we are using an IDE for that, hopefully. Of course, my preferred IDE, in case you didn't know, is IntelliJ. You have this IDE which has a lot of amazing functionality to help you be productive when you are writing the tests. There's all kinds of shortcuts that you can use instead of having to write the entire code. So you can just use some shortcuts to enable auto-completion or to auto-generate some of the code that you need. So this way, by using the features of the IDE, you can speed up the test creation. So you can write tests more efficiently, faster, and so on. IntelliJ does have all kinds of suggestions for you to improve the code that you're running. For example, it can extract lambda expressions for you, or it can, by running code analysis, show you what code needs to be improved. So this way, using all of the features of these IDEs, you can improve the code that you're writing. You can write code faster, and you can write better code because of using all of these functionalities. So it's not like you're writing tests in Notepad, because Notepad doesn't really help you with language specific things. But when you're using the IDE, make sure to use it to its full capability. That's why you're using it. That's why it's an IDE. It helps you with your code. And in order for you to be more familiar with all of the shortcuts and the goodness that IntelliJ has, you can take a look at the link I have here in the slides. This is my course on using IntelliJ for testers, and trust me, it will help you a lot to become more productive when creating your tests. Creating an in-house framework is probably one of the worst ideas you can implement. So, many times people are just going to say, oh, we need to do some automation. There is nothing out there that we can use. Let's create our own custom framework. And by custom framework here, I don't mean a Maven project where you're importing your dependencies and you start creating your tests. I mean something that tries to completely create a new tool that is similar or almost identical to something that is already out there. For example, creating the next Selenium, which is exactly identical to Selenium, or the next TestNG, identical to TestNG. This is what I'm referring to. Because when you're creating such a framework, there's many aspects to consider. First of all, you need to have written requirements. You need to know what the framework needs to do. Somebody needs to gather those requirements, write them somewhere, go over them, do groomings and so on, so that the requirements are first of all clear, then complete, and just to see that we're actually building the tool that we need. We need to understand what we need the tool for. Why are we creating the new tool? What is it going to help us with? And once the requirements are complete, which again can take a lot of time if we are talking about a very complex framework, then we need to start with the implementation. And implementing a tool from scratch takes a lot of time. Any large framework that was created for doing automation was not built in a week or 2 weeks or even 6 months. The really good ones and the really complex ones might have taken years to develop. So when you need to do automation, you probably don't want to wait so long in order to have a framework available. And when you create the framework, or somebody creates the framework, they need to create a functioning framework, a properly working framework. Otherwise, they're not helping you with anything. And because they are building something from scratch, you also need to make sure that the framework works properly. So you will need to test it. So apart from testing the features you were supposed to test, meaning the product you're delivering to your customers, you also need to allocate a lot of time to test the framework. You cannot start creating tests in a framework that doesn't work properly. Because first of all, it will be buggy, you will have all kinds of issues running the tests, and it might be the case that you will end up having to drop the in-house framework altogether and migrate all of your tests to a different framework, to something that already exists and is working properly. So creating an in-house framework is never a good idea. Just use something that is already there and is working properly. So this is the end of the talk. I still want to go over the key takeaways of the talk. Namely, we want to have quality work no matter what we are doing, and our test framework also needs to be of high quality. In order to achieve that, we will start with using coding best practices. And to have these best practices in our project, we need to learn the frameworks that we're going to use, we need to learn the programming languages before we start doing the automation so that we can apply these best practices whenever we are writing the code. Something that will also help us with following coding best practices will be code reviews, and this will be especially true if we include developers in the reviews. So feedback from developers should be very valuable to us and we should ask for it. Then we also need to focus on our tests being easy to maintain, easy to read, and scalable. We should be able to easily add new tests and to test new functionality with the framework that we are using. We also need to make sure that our tests are reliable and that we don't have any randomly failing tests, and that our tests run consistently across all of the environments where we want to use them. Our framework also needs to be well documented, at least with the minimum things like how to download the project, how to set it up, and how to get started with creating new tests and running new tests so that everybody has access to this information. Our tests need to be part of the bigger picture, so CI and CD is something that is very important to the business, because business wants to deliver product as fast as they can, and in order to do that, CI and CD play a major role. Therefore, we need to make sure that our automated tests are of a high quality, which can be integrated into these pipelines that can assure continuous integration and continuous delivery. So when we're creating automation, we need to have this as a goal. Creating those tests which will help validate the product in such a way that it will be sent to customers in a timely fashion. We need to have standards in our projects, and everybody needs to follow those standards when it comes to creating the tests and naming things and placing things in their proper place and so on. A good framework is very important because it helps us validate our products. So every aspect of developing the tests and maintaining the tests is very important. So everybody in the automation team and in the testing team should focus on following those principles. Having said that, I just want to say thank you very much for watching my talk. I hope it was useful for you. I hope it's going to help you in the future with your automation. And don't forget to check out my links here, and let's see some questions.